Hello AP Stats students. With this video, this is very short, also like the one we had prior to this about proportions. Now we're going to discuss sampling distributions with sampling means. So we're talking about quantitative data, which is actually more prevalent in a lot of statistics. It's preferred. There is more meaning to it. So we're talking about sample means, which is X bar. If we're talking about population values, parameters in this particular one, we're talking about mu's. So let's go ahead and take a look at what we have in this particular section. So suppose that X bar is the mean of a simple random sample drawn from a large population, and we will assume in the first part of this section that we're given mu and standard deviation, but in reality we'll not be given that, or if we are, then we're testing whether those particular values are true. So the mu of X bar equals mu, and the standard deviation of X bar is going to be sigma over the square root of n. So these are modified, and notice that these are the same things that I've asked you to put onto your formula sheet. The behavior of X bar in repeated samples is a lot like what we've already covered in proportions, okay, where we had the p hats. X bar is an unbiased estimator of the population mean. Now, what we also have to conclude is that we've taken all of our samples correctly, and that we have enough of them. So remember that we're looking for all possible samples of size n in a population. So we can't just take a few sample means and expect it to be an unbiased estimator of the population. We have to take lots and lots and lots and lots of samples of a particular size. X bars spread out for larger samples. Of course, we already know this is a law of large numbers. The standard deviation decreases at the rate of the square root of n. So you must take a sample 4 times as large to cut the standard deviation in half, and we've already presented that for proportions. You should only use sigma over the square root of n when the population is at least 10 times as large as the sample, and this is almost always the case in practice. Sometimes it's not quite as obvious, and so we will have to say we assume that the population is 10 times greater than the sample size in order for us to be able to proceed. And notice that these facts about the mean and standard deviation of X bar are true no matter what shape of the population is. So it can be skewed left or skewed right, but as we take more and more samples and we take the average of those samples and we create that sampling distribution, it becomes normal. Sampling distribution, this screen is mainly for the notation part of it. When it is normal, we note that the mu is mu, and that the standard deviation has been modified. It's sigma over the square root of n. So note the notation for this. It's n parentheses mu, comma sigma over the square root of n. In order to use this, remember the population has to be 10 times greater than the sample size, and we often abbreviate that with as POP. Sometimes they use P, but we have so many different P's in statistics that it gets confusing. If we use just a P, it may be assumed that it's probability instead of population. So we kind of spell out POP, or population is greater than 10n. Okay, and our book notices or says that this is rule of thumb number 1, but I would rather you remember that as a necessary condition for modifying the standard deviation rather than some rule of thumb that will change from book to book. The central limit theorem is the second component of this. Remember, in proportions, we had to do the NP is greater than or equal to 10, and the n times 1 minus p is greater than or equal to 10. Well, in means, we don't have the proportions. We don't have that p, so you're not going to use an NP is greater than or equal to 10 for means. What we do use, in order for us to be able to assume something is normal, is this called the central limit theorem. It's a little ambiguous, because if you notice at the bottom it says how large the sample size that we need for X bar to be close to normal depends on the population distribution. If the shape is far from normal, if it's really skewed left or really skewed right, then we're going to need more and more observations to assume normality. If it's kind of symmetric already, then we can use fewer sampling mean observations. So in summary, please take a look at this. We'll pause for a second, let you go over this. This is at the end of the text, but it encapsulates everything that you should know about sampling means. If you have any questions, please make note of them and ask them the next time that you are in class. Thank you.